Christy Agustina. Dear audience, if you have a question, please raise your hand. And if no question from the floor, I will ask you some questions. That is my duty as a moderator. Okay, so I will ask you some technical aspect of the study and practical implication. You mentioned your study highlight the use of the latest laser scanning technology or 3D mapping in the historical beam model. Could you discuss the specific technological challenge you face in integrating H-beam with this advanced scanning technique, particularly in capturing the intricate architectural detail of this hall, the Aula Timur, which is a historic building, and I've been visiting that place for years. Okay, that's my question.
Yeah, thank you. The challenge of mapping technology, it's for the cultural heritage preservation, it's so much challenging. If we need the model 3D for the H-beam, but the data for the mapping is an in point cloud, and we have to convert that point cloud to 3D model solid. But the problem is when the object is heritage cultural heritage, there have a uniqueness uniqueness object for the rooftop or the column is not it's so unique morph. It's a unique object. So I try to 3D model with automatic methodology, but automatic just for the regular object. So I can make build the generate or solid data for the rooftop of its hall. So I generate the model 3D solid with manual tracing digitation in 3D. That's the challenge of makes the 3D solid for the heritage cultural in its hall. Maybe for the other building of cultural heritage, that the same thing we can found if we want to modeling the 3D solid. That's for the technically, and for the next for impact for this H-beam, the next research I want to know how the H-beam trend for now for the much building, the existing building, or the planning for building can implement for the generate the zonation in site or area for management of site and area cultural heritage in Indonesia. Because in Indonesia, for technically, there's need to makes the procedural step for technically for this technology implementation. That's I think for the next research need to be more need to be more technology for implementation in other building or other object in cultural heritage in Indonesia. Excuse me, sir, you still mute?
More questions. You still
Okay.
have 4 minutes.
Okay.
My other question is on this model, the HB model, can be utilized as educational tools for students. In what way? For educational student or professional interested in heritage conservation and architectural history. But my question probably focus on educational tool for students, since you are also a lecturer.
Okay. I think, yeah, that can implement for the student of user. But for this research, I want to another user is for the expert or decision makers of orientation, how this can how the cultural heritage can be using, or how can be can be to law of uh, law of the cultural heritage Indonesia for the zona C, how the zona C of cultural heritage insights or the area of Indonesia. That's this the technically we can use this technology for the implementation technically of generate the zonation of area of cultural heritage in decision makers, I think.
Okay, thank you, Miss Lia Christy Agustina. Thank you for excellent presentation. Thank you. Please
Thank
give
you.
applause to Miss Lia Christy Agustina. And the next presenter will be Dr. David Cook, Dr. Hira Makbul from Edith Cowan University. And the title of the presentation, Early Aesthetic Integration in Digital Twin Dashboard in Isolated Agriculture, Data Modeling, and Remote Networks. Dr. David Cook and Dr. Hira Makbul, time is yours for 20
Hello.
minutes.
So I'm gonna play, so everyone can hear me clearly.
Yes.
Okay, so it's just gonna play the recorded presentation. If
I don't have in mind, so if you have, otherwise I will ask the committee.
okay, so I do have the one. So just
Okay.
gonna share. So just gonna play the presentation. Hi, I'm Ramadu. I'm here to give can a you hear the presentation on our article,
Clear,
which is
clear.
Static
Good.
Integration in Digital Twin Dashboards in Isolated Agriculture, including data modeling and remote network. So welcome to the presentation. What I will cover in this presentation includes introduction and background to the need of digital twin dashboards, benefits from inclusion of aesthetics for these digital twin dashboards, and introduction to framework, which incorporates aesthetics for digital twins. There will be some examples of weak and strong dashboards, aesthetically weak and strong dashboards, and we're gonna see some case studies, AR, VR based case studies in agriculture, and the summary and the future work. So as we all know that agriculture plays a crucial role in global food security and sustainability. As the technology advanced, it continued to reshape various industries, and agriculture has not remained untouched. The form of information visualization is also being in demand for understanding of precision agricultural concepts. This can be beneficial as large volumes of data can be easily collected, filtered, and explored for information using interactive visualization. So hectic tasks can be simplified using visualization tools in combination with tactile handheld devices or mobile phones and online technology sharing solutions. the term digital twinning has emerged. This is an accurate descriptor and depiction from the real-time environment data and representing the data in a manner that enables the efficient use of resources just using handheld devices or mobile phones. The use of IoTs, drones, and machinery has been placed under global attention to meet the needs of the population that will gonna increase up to 10 billion in 2050. The practice of digital twinning is well established in large and sophisticated agriculture establishments. But there is a wide-ranging and persistent response for the world to make use of the inexpensive benefits of the technology as part of the broad approach to the achievement of global needs. The benefits for the use of digital twins can be seen in terms of efficiencies and optimization of agricultural decision making. We are also making use of the AR and VR. So AR and VR, there have been around since 1950s, but this has been enhanced within the development of computer technology. Such real-time applications provide useful information in the form of virtually generated objects such as sounds, graphics, or text, through which people can interact to get real experiences through virtual contents. And in addition, it's possible to use these applications on handheld or mobile phone devices. So there is a reduction in supervisory cost for the livestock and crop farming. One factor that can affect the user experiences for such applications is aesthetics. So what does aesthetic means for such applications? So aesthetic refers to easy to understand and easy to interpret visualization of the data. So why it's important? Because aesthetics is the representational component of a broader range of sensory experiences such as interest, intrigue, positivity, and credibility. Applying appealing, easy to understand and easy to interpret and trustworthy aesthetics to certain objects changes their meaning and overall perception to the user. So aesthetics and functionality both need to be considered by the designers and developers of agricultural dashboards. Functionality is required for users' adaptation. Aesthetics that includes easy to understand and easy to interpret data required for users' positive perception. So this article actually explores the aesthetic AR and VR in agriculture and highlighting the impact on productivity and sustainability and the visual landscape of the farming. So what are the benefits of inclusion of aesthetics? So to be clear, aesthetic here means easy to understand and easy to interpret visualization of the data. So this can improve user experience and engagement, provide immersive experiences to the user by using combination of the virtual and real worlds. So when a user is surrounded by an immersive and aesthetically enhanced environment, the inclusion helps in elevating awareness and consequently elevates the user's presence and interaction with each application. Engagement is an important factor for such applications along with immersion. In addition, some retention and understanding can be enhanced with better immersion and with better visualization of systems developed for education and training. So we can also develop AR and VR based applications which can provide more immersive interactive learning experiences, and it is safe for training young students. So the concept of digital twinning is increasingly entering livestock farming strategies. This allows for developing technology and permits increase in the number of human population and ongoing trend towards urbanization. So in this article, there are also some case studies which are AR, VR based case studies has been discussed. So just to understand and highlight the importance of aesthetics inclusion. So there are case studies which include dynamic water consumption. So there are also dashboards which includes in the agriculture. So it is citrus yield. So drawback of this was that it was only developed for the citrus yield. Then we have the precision farming using AR and VR based applications, and we also have the crop monitoring using AR and VR. The framework, which is actually DATM framework, is used for increased immersion with dashboard and digital twin management. This encourages thoughtful visualization and careful structure for scenes. It also encourages the user-centered design principles, which are very important for any creating any appealing, which is easy to understand and easy to interpret handheld visualization of the data. So this is actually focuses on developing applications which are used for the handheld devices. So here are some examples of aesthetically weak dashboards. Here you can see that we can see some graphs and we can see some numeric data, which for any farmer will not gonna make any sense. So on the other hand, if we have a aesthetically strong dashboards, we can see that the words like poor, good, and the icons like the fire icons or the water droplet icons can have a more visual impact, especially when they are using the handheld devices, which is easy to interpret and visualize such kind of data. So summary and the future work includes that the aesthetics of AR and VR are reshaping the agricultural landscape, and therefore we need to develop such kind of applications which enrich the visual experience of farming practices. As technology continues to evolve, the harmonious fusion of digital and natural elements in agriculture will likely to inspire new generations of farmers, consumers, and stakeholders. The future work of this study will focus on specific areas of agricultural challenge and global concerns. This will also include the future for digital twin dashboards will going to apply the DADM model into detailed and specialized area where dashboards management by farmers requires uplift, technology acceptance and application, especially using handheld mobile phones or the handheld devices. Thank you so much for your time. If you have any questions, please do let me know. Thank you.
Thank you, Dr. Hira Makbul. Thank you.
Thank you.
We have 11 minutes, then I open the floor for questions. Then I will ask questions. You, in your presentation, you mentioned about the decision-making process that lead to effective deployment of digital twin in agriculture.
Yes,
And
that's right.
how do these factors vary across different agricultural contexts? Since you plan to do future research, what is different, or how do these factors vary across small-scale farm versus large-scale agricultural enterprise? I remember in one of your slides, one is the weak dashboard and another one is the strong dashboard. So in strong dashboard probably is easier for the small scale farms, but then more quantitative probably for large scale agriculture, but that's also, it can be contradictory. So what is your comment, especially in perspective of small scale and large scale agriculture?
Okay, so the concept here is to develop dashboards which are actually visually acceptable. So here visually acceptable means easy to understand and interpret. So it doesn't matter like scale of the farm, but it does matter how those results or sensory information or the information obtained from the sensors is represented to the farmers. So what we have experienced is farmers are not that educated. They don't understand the bar graphs or the line charts, which are given within the dashboards. So what they understand is the visual information, like where there going to be a high temperature, how much humidity would be there, like in terms of visual information. If you just look at the strong dashboards, you can see the very highlighted information there. Like it could be in terms of words, like easy to understand words like poor, good, or anything, or it can be in the form of icons like shapes, maybe as I have, if I'm just gonna share the slide again, so if
Yeah.
that's make a sense. So if you just look at these strong dashboards, so you can see that there is an icon there which is actually showing the moisture, which is a moisture detector, right? So it is in the form of a water droplet, so it's saying something there, water required. So simple explanation can like this can really help farmers. But if you just look at the weekly design dashboards, so here I think the temperature or the moisture line, the line given, the line given is in the form of a, sorry, the moisture given in the form of a line is will not be understandable by the farmer. So this is what we want to do. We want to simplify the complex information, which is easy to understand by the farmers, especially the one who are not that educated, which usually rely on these dashboards to monitor their crops or monitor the climate and the weather conditions. So this is what our intention is basically.
Follow-up questions. Are there any are there any specific design elements that have been found to significantly enhance decision-making capability of user? The specific design element, that's number one. And number two is that, is it different between if your user small scale farmer and the large enterprise farm?
So you're basically asking, is there any difference between the design of two different forms?
First, a specific design element, do they have different, or it will be cross-board the same?
So focusing on the design elements, so that is what we have intention of doing in the future. We're gonna do the analysis based on different dashboards, and we're gonna compare those results, and we're gonna be kind of a user-based study in which we're gonna consider asking farmers which dashboards they think is more easy to understand and interpret. So this is one of the future works, future intentions, like to pick out the design elements which can be used for designing the dashboards. Secondly, you're asking about the scale of the dashboards.
Yeah.
So
User.
sorry, scales of the
User.
forms, like simple small scale forms and the large scale forms. So it definitely depends upon the level of education the farmers are working there. So if they are like highly educated farmers, so obviously they can understand more complex dashboards. If they are like less educated farmers, then obviously we need to focus more on the visual representation of data than as compared to just graphs and lines. So I think Dr. David Cook will gonna highlight this as well.
Yes, please.
So, Bapak, I'm sorry, because both Hira and I wrote this together, I feel like I can add some additional information which helps to explain this. One of the changes in the way in which agricultural data is collected now is through the multiple deployment of IoT devices. So if we look at how IoT devices are put across the landscape, it doesn't have to be just farming. It could be any other enterprise. So it could be earthquake monitoring, it could be climate change or whatever. But in farming in particular, we have seen a rapid increase in the number of IoTs. What that has given us is a huge amount of numerical data, very simple numerical data. And this has changed the way in which people view different information. So whilst Hira was bringing out the point about the difference between many farmers who, whether it's in Australia or perhaps in Indonesia, but certainly in Australia, the average farmer is not a well-educated person. So they do not understand complex numerical structures if they're statistically aligned. If they're put into simple bar graphs or very simple visualizations, then they can make generalizations and do something. But the other big difference which has changed now is that much of the farming landscape has a broad acre, a much wider conceptualization. And what this means is that different devices are used on systems which have low bandwidth. So they're not deployed on 5G or 4G mobile devices, but they're on much, much lower kinds of deployments. So 3G, in many of the cases on farming institutes, they're used on long-range, wide area networking, where it's only possible to have just simple numbers. So you might be talking about the amount of rainfall, and you're just measuring it in a simple number, whether it's 20 millimeters or 25 millimeters, little things like that, as opposed to a much more complex way for a large scale. So you mentioned the difference between, what is the difference between large enterprises and small enterprises? Yes, there is an education element, but I think the most significant part also now is the bandwidth, the way in which the information is presented. So if we want a typical farmer to look at this information and to make optimizations, in other words, to look at this all the time, not once a day or once a week, but look at it on an hourly basis, they can make very important changes. If you take someone who's a farmer in, say, mangoes, who is trying to work out the perfect time to pick the mango crop so that it can go to market and can be sold for the most amount of money, those kinds of optimizations are the sorts of things that this new approach to dashboard management will change. It will mean farmers will make clever decisions based on visualizations that they can interpret, rather than trying to be complex about it, as opposed to agricultural scientists who can sit away. This is a just-in-time proposition. They need to be able to see, visualize, and act very quickly.
Follow up, Dr. David, questions? I can ask to Dr. David. Since you mentioned about the low band. So meaning if you have the high band, probably it's different. Probably the aesthetic feature less important in the high band quality of network, is it? Is it that?
It is the big challenge, because all of our measurement devices are on IoTs, and so they're much easier to deploy in low bandwidth situations. That's the challenge. And currently there are scientists working everywhere to try and extract the most amount of information from low bandwidth situations. So the most obvious example of this is in the way that we use typical sensors. I'll give you one example, LiDAR sensors. So LiDAR sensors are used in modern cars to detect motion of objects. They're used in drones to detect collisions with a tree or a plant. And LiDAR sensors on farming enterprises allow us to use numerical data to then refashion that data into the shape of an animal, the shape of a crop, the shape of a particular kind of piece of produce, whether it's coffee plants, mangoes, any number of things. So the challenge is about using sophisticated measurements and somehow sending that information in low bandwidth situations and then recreating something which is visually so clever that people can make good decisions. That is the challenge, and that's what our research is based on.
Thank you. Thank you for your research. Dr. David Cook, Dr. Hira Makbul, for your presentation. Excellent presentation and insightful. Thank you. Thank you. Give applause. And now we continue for the last questions. For the last presentation of this exciting session. The title is Mapping Urban Income Pattern via Geospatial Based Expert Opinion Technique in Selangor, Malaysia. The author was Abdul Rauf Abdul Salam, University Teknologi Mara, Malaysia, Nur Aizam Adnan, and Zahara Muhammad Yusuf. And time is yours, 20 minutes, and it starts now. Thank you. No,
Can I share my slide?
Yes, yes.
Everyone can see the slide?
Yes.
Ladies and gentlemen?
Yes.
Okay.
Yes, Dr. Abdul Rauf, you can start.
Okay. Assalamualaikum and very good day, everyone.
Waalaikumsalam.
I'm Abdul Rauf Abdul Rassams. On behalf of my team members, especially my students, present a research topic entitled Mapping Urban Income Pattern via geospatial-based expert opinion technique in Selangor, Malaysia. We actually from the School of Geometric Science, Natural Resource, College of the Environment, UITM, Shah Alam, Selangor. So these our main points started from the introduction and ended with the conclusion. Ladies and gentlemen, introduction. Why income status is very important, especially for the Malaysia? Because we can talking about the income actually is reflect on the situation of the community of the people. We look at the figure, actually the map, most of the higher income of the community states located in the Peninsula Malaysia compared to Malaysia Sabah. Why? Okay, there's a many method to map it, but I believe that GIS and also mapping can be used for more better analysis and also for more better for prediction analysis and making decision making. So this is very important for our agency to predict and also to plan systematically for our society. Ladies and gentlemen, we're talking about the household income in Malaysia. Actually, it can be categorized into three categories. First, B40, M40, and T20. B40 meaning that below 40, M meaning middle, and T is top of first class. So basically, what the income actually for the B40? B40 actually is less than around 5,000 ringgit Malaysia or around 1,000 US dollar. So the people who's recorded a salary more than 2,000, we call is T20. But actually, how much monthly actually income do you want to need comfortably in Malaysia is based on the location. If you located in Kuala Lumpur, so more money used to comfortable in Malaysia rather than the another state. So the problem statement is about the low income. Low income actually maybe there's no problem for the rural area, but actually even though your income is higher, but if you're staying or you're working in the highest urban area in Malaysia, so not wonder if you categorize as the urban poverty. So actually, even though we have a system, we call it online census system, but this system actually still have a weaknesses, especially in terms of the to get the reliable data and also the data. There's no database map, but this situation actually lead to the drawbacks or some limitation for the agency, for our agency to do something planning. So I believe that GIS have a potential to not only to display the map, but also to analyze the real situation of the urban poverty scenario in Malaysia. So what the study aim and objective, the study actually is to estimate the urban income, especially one the urban area, so we call it section 8, Kota Gunung Damansara, Selangor, by using GIS and also our remote sensing. So they have a three objective. First is to create the updated base map. The second is to create the database. Last but not least, to estimate the urban income status. And directly, we can predict what the current situation of this study area. So this study areas is located in Selangor. So Selangor actually is the most developed state in Malaysia, beside the Penang or also Kuala Lumpur. So we believe even though the area is very developed in urban, but believe me, there's some people that have low income. So research methodology, they have four stages applied in this study. Actually start from the preliminary study, okay, the preliminary study and followed by the data collection. So the data collection, they have a four main data set used in this study. We start from the remote sensing imagery that's come from AGES online, and then we also get the data from the local agency, average gross household, and we also need from the expert yeah, the expert to know and identify the real value of the income population. And besides that, we also have the another spatial data, we call attribute data, related with the building, housing, and others from the Google Map. For the third stage is data processing. Data processing actually is involved the base map. The base map actually we get from the digitizing picture GIS and also from the remote sensing, extraction remote pictures from remote sensing imagery from AGERS online. And after this three process, so we get the result. The result is actually is parallel with the objective. So after completing the all of, objective, so we can produce the post result, which are updated base map, and then we have a updated database of urban building areas, and also urban income status analysis and scenario of the study area. So the first result is updated base map of urban pictures topography. Why this updated pictures is very important? Because what? The previous map produced by the local agency actually is still the old outdated base map. So if using the outdated map of to analyze something, I think is a rubbish. Yeah. So the concept of the GIS actually garbage in is garbage out. That's why we need to update the database based on the multi-integrated method for the GIS remote sensing and also from the expert opinions. So another result is a second result is the database. This database is related with the urban building area and also estimated income. Okay. The last result is estimated urban income status poverty using GIS and also expert opinions. So based on the expert opinion and also the existing secondary data, so we can identify uh, uh, qualitative value of the income level. So the color the darker color is show the low income, so the light color show the high income. So looking at the secondary data, so most of the low income actually is located in apartment, people that located in the apartment and also flat. So the people who staying in the bungalows, Sumidi recorded, yes, they have a high income. So based on the site visit that we conducted in the study area, so most of the area that recorded the locals of low income actually uh, is surrounded by low low uh, low residential area compared to high residential area. So, so after estimated predict the income, so we need to validate it first. How we validate? So they have two ways. First, based on the site visit, we go to the web CZ and also by interview the expert, the local expert for the Putrajaya Council department. Is it true? Is match is the result from the previous result is actually is consistent with the validation of what we have done in the study area. Okay, as I mentioned in the previous slide, most of the low income actually is located in the Southern Asia. So because this area actually most of the area the residential area is department in apartment flat and also condominium. Okay, so based on this based on the map that produced actually and we also did a site visit in the study area. So some fact of the urban poverty in the study area. First of all, this area actually has been yes impacted by the pandemic COVID-19. So the the people in category B40 has been hit the hardest and with debts, jobless, loss and income. So this actually revealed that 30% of the M40 have now joined the B40, which is a low income. So we also identify that poor living condition, a government inaction, exploitation of worker. So what we need to do actually, the government, especially the local agency, need to do something to help the people after the COVID-19. So this is overall conclusion. First of all, yes, geospatial or GIS need combined with the expert opinion to estimate and also to export the real situation of the income status, especially in the urban area. Okay. For the recommendation, okay, we believe that this is very good tools because the combination geospatial and also expert opinion, to try to replace the manual or the existing method. However, we believe there's some consideration we need to do in this study area. First of all, add more information, especially for the facilities, services, and population data. And also, maybe we can do the advanced GIS regression analysis or artificial intelligence, machine learning to do something a better result or also the planning strategies. So that's all, ladies and gentlemen. Thank you for your kind attention.
Thank you, Dr. Abdul Rauf Abdul Salam. And I have opened the floor for questions. We still have 8 minutes. Then I will ask for the question. How you ensure the objectivity and the consistency of the expert? Because this is, in your presentation, social economic, it's very sensitive. Poverty area and classification is very sensitive. It's not only in Malaysia, also in Indonesia. This is a subjective plus objective. How you ensure the objectivity and the consistency of the expert opinion?
Okay, thank you, Dr. Oni, for your question. It's very interesting. Yes, when talking about the social science, it's something it can be objective and subjective, but especially we identify whether our result is reflect the reality, right? Okay. First of all, if you based on the current situation, actually is take a time to update the income. So the best way actually, whether our local agency workers go every day or every week, but it's impossible, okay, because the manpower limitation and also cost budget constraint. So the best way is maybe we can combine with geospatial like artificial intelligence, remote sensing, and others. But there's still some limitations. So what we call is we need to combine digital and manual, semi-automatic. So we call our method is more semi-automatic. So we try the base. First of all, in terms of the database, okay, database actually we based on the secondary data. Okay, but the secondary data still doesn't reflect the reality because it's outdated. Okay, what we need to update it. So see, this study actually is still the preliminary study, but we try the best to make sure our result is very conclusive and maybe accepted by the local agency. First, we need to update the database of the income, estimate income of the local and also database. Okay. Next, we try to verify. We try to discuss with the local person, but the only one I think the only person that is very reliable person that can be verify the result is Mr. Isham. Mr. Sam is the one that head department of the social strategics in this Petalinjaya consuls departments. So because he has experience more than 20 years, okay, that's the best way that we can do to make sure our result is consistent, our objective and also the result is very consistent. But if you ask me about for the better result, actually there's many method. First of all, maybe after this we need to discuss with the more respondent, especially for the local community or residential area. That's all that. Dr. Oni, I can't hear you.
Okay.
Please off.
Is there any question from the floor? Otherwise, I will follow up question. So speed versus reliability. So in this case, is speed, it's more important. That's what I understand. The quick result is more important than the reliability of data. Then
I would like I could share for this because the study is still in the progressing actually. So first of all, what we need to do is how to update the data in the short time compared to the existing method. Maybe the second time or the second stage is more the reliability of the data.
Okay. Okay. Dr. Abdul Rauf Abdul Rasam and Dr. Siti Normaisara Abdul Halim, thank you very much for your presentation, and we hope we can see your next presentation or your latest presentation. Please give applause to the last presenter for today, Pak Abdul Rauf Abdul Salam and Dr. Siti Normaisara Abdul Halim. And now,
thank you very much.
Yep. And now we came to the end of the presentation, but as proof that we have this meeting and this presentation, we need to have some group picture and that we can send to the IEEE that we have this meeting. So for the audience, please open your video so that we can make a group picture. And the committee, please make a group picture. And I will count 1, 2, 3. 1, 2, 3. So, dear presenter, thanks, dear audience, thank you very much for your presentation and awesome presentation and discussion. I hope we can see you in the next presentation. Tomorrow is day 2 for AGERS 2023, and there will be some announcement. Also, if you still have some administration, house administration, please do that. And I hope that we can see the result of your conference or presiding and the next couple of months. And probably we can see you again in the next AGERS 2024. Ladies and gentlemen, thank you very much for your presentation and have a nice, good day for today. Thank you very much.
Thank you, Pak. Thank you, Dr. Oni. Thank you, everyone.
Thank you, everybody.
Thank you, sir. Thank you, everyone.
Thank you, everyone.
Thank you, Professor Oni. Thank you.
Thank you, everyone.